In this video, I will explain what the purpose is of multisignatures and how to use IOTA multisignatures. Multisignature or multisig refers to requiring multiple signatures to authorize a transaction. There are two types of multisignature schemes. N-of-N scheme. All co-signers need to provide their signatures in order for a transfer to be successful. M-of-N scheme. M co-signers of a total of N co-signers needs to provide their signatures in order for a transfer to be successful. This is an N-of-N scheme, where 3 participants each need to sign the transaction. This is a 3-of-3 scheme. This is an M-of-N scheme, where 2 participants, this participant and this participant, needs to sign the transaction. This is a 2-of-3 scheme. This is a 2-of-2 scheme. There are 2 participants and each participant needs to sign the transaction. This is a 1-of-3 scheme, where only 1 participant needs to sign the transaction. In this tutorial, let's assume Alice is the notary. Bob and Charlie are business companions buying an office space worth 2 IOTAs. Yes, that's cheap. Alice uses a 3-of-3 scheme, which means 3 signatures, Alice, Bob, and Charlie, are required for a successful transaction. Alice is the organizer and will handle the multi-signature process. For educational purpose, you can use the Multisig wallet. This wallet. Do not use this Multisig wallet in production. You will lose all your IOTAs. Alice, Bob, and Charlie each creates a digest using their seed and an unused key index. They can all use a different security level. This is Alice's seed, key index, and security level. And these are Bob's and Charlie's seed, key index, and security level. The sum of the security levels is 2 plus 1 plus 3 is 6. This value will be used later. Alice, Bob, and Charlie's seed, key index, and security levels can be found in this location. This is Alice's seed, key index, and security level. This is Bob's seed, key index, and security level. And this is Charlie's seed, key index, and security level. All Multisig APIs can be found in the IOTA JavaScript library. See this link. The API to calculate the digest is iota.multisig.getDigest. You need the seed, key index, and security level as input. The getDigest function is just a wrapper. Under the hood, it calculates the subseed, then the key, and finally the digest. The subseed is created by adding the seed and the key index together. Here is the seed in trits. This is the key index. You add these 2 values together and you will have the subseed. This transformations function absorbs the subseed and squeezes out the result. The result is absorbed by this transformation function and uses the security level to squeeze out the key, which is the private key. This key is absorbed in this transformation function and squeezes out the result. This result is used as input in this transformation function and it squeezes out the digest. Again, here is how the digest is calculated, but more detailed. You start with the seed, the key index, and the security level, which calculates the key. This is the key. This is a segment consisting of 81 tries. Each segment is hashed 26 times. These are called key fragments. 27 segments forms a key fragment. And if you hash each key fragment once, you get the digest. If you have selected security level 1, you will have this digest. If you have security level, you have this digest. And if you have security level 3, you have this digest. Now let's see how the digest is generated using this web application. Select this option, Generate Digest. Select this testnet. I already have a seed. Select this option. Let's calculate Alice digest. Copy Alice seed, paste the seed, and store the seed. This seed is stored in the browser session storage. Alice uses key index 24 and security level 2. Security level 2 and the key index is 24. Press the button Generate Digest. And here is the generated digest. If you select this checkbox and press this button, it will also generate the private key. The private key is used in the M of N scheme, which I will explain later. You can do the same steps when you generate Bob's and Charlie's digest. The generated digest and private key can also be found in the multisig_demo text file. Bob and Charlie can safely send their digest to Alice because Alice cannot reconstruct their private keys using their digest. Alice, in her role as organizer, uses all three digests to create a multi-signature address. Alice creates a digest array consisting of her digest, Bob digest, and Charlie's digest. This digest array is used as input in this iota.multisig.address API, which calculates an address instance. This address instance needs to be finalized to get the multisig address. The digest order is very important. See the digest array. Later, when the bundle needs to be signed, the same order must be used. In this example, the order is Alice, Bob, and Charlie. There is no difference between a multi-signature address and an ordinary address. The size of a multi-signature address and an ordinary address are both 81 tries or 90 tries with checksum. This is a simplified explanation how the multisig address is calculated, as you can see in this picture. The order of the digest is very important. In this picture you can see 3 digests, but you can add more digests. The size of the multisig address is always 81 tries. These digest size depends on the selected security level. The size can be 81 tries or 162 tries or 324 tries. Now let's calculate the multisig address using this web application. Select this option, Generate Multisig Address. Select this testnet endpoint. We have 3 cosigners, Alice, Bob, and Charlie. Select 3. Enter in these 3 fields the digest. Enter the digest in the correct order. Enter Alice digest in this field, then Bob's digest, and then Charlie's digest. After you have entered all digests, press this button. And this is the generated multisig address without checksum. And this is the generated multisig address with checksum. The sum of the security levels is 6. And for verification, I also display the entered digests. These values can also be found in the multisig_demo text file. Alice has created the multisig address and sends this address to Bob and Charlie. Bob and Charlie can now each deposit 1 IOTA to this multisig address. Alice verifies if the multisig address contains 2 IOTAs. After the verification, Alice creates an initial bundle. In this particular example, the complete amount in the multisig address will be sent to the recipient address, which means no remainder address is needed. The API to generate the initial bundle is iota.multisig.initiateTransfer with input, remainder address, and transfer as input values. Input consists of the address, which is the multi-signature address, and the security sum, which is the sum of the security level, which I have explained earlier. In this example, we don't have a remainder address. And transfer consists of the address, which is the recipient address, the value, which is in this example 2 IOTAs. It can contain a message, and it can contain a tag. For a better understanding how the iota.multisig.initiate transfer API works, see IOTA tutorial 15, where I explained the bundle hash, and IOTA tutorial 16, where I explained the normalized bundle hash. I will now demonstrate how the initial bundle is generated using this web application. Select the Create Bundle option. Select this testnet endpoint. The sum of the security levels was 6. The multisig address is this. We have no remainder address. The recipient address can be found in the multisig_demo text file. Here it is. In this demo, Bob and Charlie both have transferred 1 IOTA to this multisig address. The amount is 2, which means 2 IOTAs are sent from this multisig address to this recipient address. Enter the message office space and the tag demo. Press the button Create a Bundle to sign. And this is the generated initial bundle. This generated initial bundle can also be found in the multisig_demo text file. Please note, the initial bundle displayed here differs from the initial bundle you see here. I have created this video at 2 different times. Let's see the generated initial bundle. As you can see, here is the generated initial bundle. There are 6 transaction bundle entries where the address equals the multisig address. In these entries, the signature message fragments are empty. Here is the multisig address, and as you can see, the signature message fragment is empty. This is the second multisig address, and again, the signature message fragment is empty. Again, here's the multisig address, and the signature message fragment is empty. The same applies to this entry, and this entry. The initial bundle can now be signed. The signing order, meaning Alice, Bob, and last Charlie, is the same as the digest array order. First, Alice adds her signature to the initial bundle. The modified bundle is now called first signed bundle. Alice sends the first signed bundle to Bob, and he adds his signature to the bundle. The modified bundle is called second signed bundle. Bob sends the second signed bundle to Alice. Alice checks if the relevant signature message fragment fields are modified. Alice sends the second signed bundle to Charlie, and he adds his signature to the bundle. The modified bundle is called third signed bundle. Charlie sends the third signed bundle to Alice. Alice checks if the relevant signature message fragment fields are modified. I will now demonstrate how Alice adds her signature to the initial bundle using this web application. Select option Add Signature to Bundle. Select this testnet endpoint. Alice can enter her seed, security level, and key index. Please note you can also enter a private key. The private key is used in an M of N scheme. So you can use the seed, security level, and key index, or you can enter the private key. Use the private key only in an M of N scheme. I have entered Alice seed in this field and stored the seed in the browser session storage. I've selected security level 2. I have entered key index 24. I have entered the multisig address. And I have pasted the initial bundle in this field. Press the button Add Signature to Bundle. Alice's signature is now added to the bundle. This generated bundle is called the first signed bundle. You can repeat these steps for Bob and Charlie. Enter their corresponding seed, security level, key index. The multisig address is of course the same for Alice, Bob, and Charlie. For Bob, the bundle must be the first signed bundle, and for Charlie, you need to enter the second signed bundle in this field. See the modified first signed bundle, second signed bundle, and third signed bundle in our Multisig demo text file. Here is our Multisig demo text file. This is the initial bundle. This is the first signed bundle where Alice has added her signature. This is the second signed bundle where Bob has added his signature. And this is the third signed bundle where Charlie has added his signature. The third signed bundle is also called the final bundle. Please note, the 6 transaction bundle entries where the address equals the multisig address all have non-empty signature message fragment values. If you look in the final bundle, this is our multisig address. As you can see, the signature message fragment is not empty. This applies to this entry. 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 And this applies to this entry. All 6 entries where the address has the multisig address. The API to add signature to the bundle. First, you need to calculate the private key using the iota.multisig.getKey API. Next, you can add the signature using the iota.multisig.addSignature API using the bundle, the multisig address, and the private key, which we have calculated previously. For a better understanding how the iota.multisig.addSignature API works, see IOTA tutorial 17, Create and Validate a Signature. As mentioned earlier, the third signed bundle is called the final bundle, and Alice sends this bundle to the tangle. The API to send the bundle to the tangle is iota.api.sendTrites. In the next slide, I will explain what this value is. You parse the final bundle, and we call it the parsed final bundle. We create a trites array. We loop through the parsed final bundle and convert each transaction object entry to trites and add it to the trites array. The trites array is reversed and is used as input for the iota.api.sendTrites API. Now I will demonstrate how Alice sends the finalized bundle to the tangle. Select option Send the finalized bundle to the tangle. Select this testnet endpoint. Paste the final bundle in this text field. Press the button Send Transaction. As you can see, the bundle is successfully attached to the tangle at this address. By attaching the bundle to the tangle, it means that 2 IOTAs are sent from the multisig address to the recipient address. What if Alice decided to use a 2 of 3 signature scheme? You always need the signature of all participants in the scheme. This means, according to the documentation, an M of N scheme can be set up by sharing private keys. Example 1. A 2 of 3 scheme means each participant in the scheme should share its private key with 3 minus 2 is one other participant. Example 2. A 2 of 5 scheme means each participant in the scheme should share its private key with 5 minus 2 is 3 other participants. Example 3. A 2 of 4 scheme means each participant in the scheme should share its private key with 4 minus 2 is 2 other participants. So if Alice wants to use a 2 of 3 scheme, Alice gives her private key to Bob, indicated by this notation. Bob gives his private key to Charlie, indicated by this notation. And Charlie gives his private key to Alice, indicated by this notation. This means in a 2 of 3 scheme, 2 participants will have all the necessary signatures in order for a transfer to be successful. Here are a few other examples. By the way, A, B, C, D, and E refers to these persons. For example, in a 2 of 5 scheme, Alice needs to share her key with Bob, Charlie, and Dave. Bob needs to share his private key with Charlie, Dave, and Eve. Charlie needs to share his private key with Dave, Eve, and Alice. Dave needs to share his private key with Eve, Alice, and Bob. And Eve needs to share her private key with Alice, Bob, and Charlie. When setting up an M of N scheme, keep an eye on the following. The whole process must be transparent to all its participants, meaning each participant must receive and understand the complete M of N private key sharing scheme. Sending the private key to participants must happen securely. Users must share their private key with only the assigned participant or participants and no one else. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.